Welcome to the channel where all you gotta do is get this 462 valve head to flow something. So my Bronco project here, I'm gonna get started on this. Well, started back on this again soon. It's quite far along actually. No, it doesn't look like it. And there's a bunch of junk piled on it right now, but this is just a mock-up frame. I have the real frame for this sitting outside, but this one is just to mock up everything. And, in case I screw something up, I can go back and get the real frame out. But basically, this is a 462 valve. The exhaust system is done. It's essentially the same header on both sides. This is actually an aluminum block out of an Explorer with an Allen M90 supercharger on it. And a ZF 5-speed and Atlas transfer case and a GT42 ball bearing, and then some. This is what I call a diff box. So basically, the suspension arms get attached to this box, and it rotates to get more articulation. So you get the benefit of a solid axle when you're rock crawling or wheeling, and on the road you get the suspension, the supple suspension of an independent front and independent rear suspension. So yeah, this is the same header that's on the other side. I bought 2 sets of headers and threw away the right side, I think, and then I used left on both sides. Just packaged nicer, and I didn't really want to remake an entire header, so all stainless steel exhaust, and then back through the muffler and out yonder. There's a whole bunch of other stuff that is done on this thing. The engine's kind of bigger than the Windsor that was in it, so I had to make a little hole there. This is the piece that goes in to fill that hole up. So a bunch more stuff. There's a dry sump tank up there. There's also onboard air, yada yada yada. 44-gallon fuel tank with swivelly pumps. Anyway, I'll get into this a little bit more. For now, since that thing has a 462 valve and dead stock heads, I need to fix that when I put that engine back together. It also has a saw forged rotating assembly in it right now, and I have a 8-bolt crank to go with the V10 transmission flywheel. I digress. So this is a 462 valve head that I found on Facebook. Well, I found a whole engine. The guy wanted a 6-pack of Pepsi for it, so I obliged him. Gave him $50 instead. But when you pay $50 for a motor on Facebook Marketplace, this is what you get. Yeah, that's a lightweight piston right there. But I wasn't going to use it for that anyway, so this is what the stock port. This is the side that didn't have the explosion. So that's what the stock combustion chamber looks like. I've cleaned this one up a bit. So that's the stock combustion chamber there. It's got this swirl dam in here. So basically this is intended to reduce the flow out of the bottom side of the valve here and reduces the flow overall, but it gets most of the flow coming this way, and it's kind of a tumble port as well. So they're trying to generate swirl in this direction to get a faster mixture. Swirl's good, but this is excessive. And if you really want swirl, you can get it without ruining the flow. So this is the main difference between the PI cylinder heads in the older ones. The swirl dam on the earlier ones came all the way down to here. See if I can find a picture of that and pop it up here. But and then the distance to the valve was even closer. Let's pop this valve out of here. So this distance here is about 2 millimeters. There. It was even closer. It was like 1 millimeter away on the early heads. The 91 through 98 heads. So what I've done is I kind of chopped that swirl dam off of there on this cylinder and then filled this in with clay. So I'm going to flow this guy as a baseline, which is pretty terrible. And then I'll flow this guy with just this combustion chamber mod. And this combustion chamber mod will improve flow probably. Obviously getting rid of this is going to help flow, but all this area here is not good for the air coming out of there and smashing into this. And, right, you want something smooth and no little nooks and crannies to get chunked into. The other thing that's kind of interesting about this is this valve. See that margin? Oh. So the width of the valve at the bottom here, that's called margin, and this one has an excessive amount of it, which typically improves flow. Likely why they did it, but it makes the valve heavier and more expensive to make. But typically it only helps flow when you have a dump port, which is a port that, well, it dumps, right? This is a tumble port, essentially. So the air is coming around the corner and just keeps shooting off. I'm a little bit confused on why they did this. They may have tried this out with a conventional port, like a dump port, and it went, wow, look at the gains, and they switched to a tumble port and didn't remember to get rid of it. I don't know. It seems like Ford should be smarter than that, but in my experience, this margin only helps when you have a dump port. When you have a, maybe they left it in there because it does a better job of shrouding the flow with this eyebrow in here. I'm not sure, but I don't have a swirl meter on my flow bench, but I think I'm probably going to add one because they're pretty simple to whittle up. So I'll probably just add one of those, and then we'll have swirl data, because the cylinder head designer, port designer, they're doing multiple things, right? They're trying to make it pass emissions, they're trying to get good fuel economy, trying to make as much power as possible, detonation tolerance, lots of stuff that they're trying to do, and they're all kind of, well, they make it cheap. And they're all kind of going against each other, right? If you want to make a really high flow port, it's going to have not much charge motion, and it's going to get shitty economy and the shitty emissions. So, so somebody's, put some thought into this. This isn't a shit design, right? But for performance engine, which of course you want in a Bronco, I think there's some pretty simple improvements that can be made to it. So I'm also, I have all the tolerances or the dimensions for this cylinder head, and I'm drawing one up in CAD, and I'll probably either machine or 3D print a flow box, and then it'll be missing all the same stuff, like the spark plugs in the same spot, like head bolts are in the same spot, head bolts and cam towers, and all the junk that you got to miss with the port. You can't just put it anywhere. So I'm gonna draw something up and then flow that and see what could have been. I know TrickFlow basically did that same thing with their twisted wedge. It does flow better than this, but that's not because of the twisted wedge. It's because they put bigger valves and bigger ports. Like, yeah, it's going to do that. So anyway, and they moved some stuff around in the combustion chamber and got rid of this fucking disaster of swirl dam. But anyway, I will get a swirl meter rigged up and put in my flow bench, and then I will start flowing these guys and this guy, and we'll see what it does. But my prediction is this is going to be pretty terrible. Probably, I don't know, 200 CFM or something like that, 190 to 200, and shit on the exhaust, like 150 or something. And then this is probably going to gain 20 CFM, 15, 20 CFM, something like that, just by getting rid of the swirl dam. And then I'll start laying into it. And I have 4 in this, 4 on the other head to play with. And I also need to section these to see what water jackets and stuff in there. I can use this little guy here for some of the stuff. Show you how that works. But you can see in here, that's the other side of the port from here. So if you just take this guy here, jam it in there, you can see that has 6-ish millimeters of thickness between there. And you can move it around and see how much you have here and there and everywhere. You can't do it inside, but that's why you got a chop saw, and you just sacrifice a head. This one could probably be made into a good head, but it cost me $50 for 2 heads and a block and a bunch of spare shit, so probably cost me more in fuel to go get it. But anyway, that's what we're up to. I don't know if you can see the shape of that combustion chamber that I kind of sculpted with modeling clay, which will be fine for the flow bench, but we won't try to run that. Okay, so did a quick dry erase board drawing of a cylinder head with a tumble port and a dump port. So basically, valve in the same spot in this scenario. So a dump port has a nice short side here, so it gets the air kind of going in the direction of the axis of the valve, and so the flow coming off the valve, it goes around the valve like that and kind of goes down. Now that doesn't generate much charge motion to mix up the air and fuel, whereas if you use a tumble port, you'll lose some flow. So the flow basically comes over the valve like this, and then it hits. You do get some impingement on the wall, which is not good for crevice volume, but so most of the air kind of ends up over here. And if you have a scenario where you have a 2-valve motor, then that creates some swirl, right? Because it's off center, right? The exhaust valve's over here, intake valve's over here, so you get some swirl motion. On a 4-valve, it also is advantageous, because what you have is on a pent roof combustion chamber. Here's your cylinder bore, your pistons down here somewhere. What you get is, from a tumble port, is you get the air flowing like this, right? It's not going straight down. So when the piston starts coming back up, it creates this crumbling motion where these things kind of, they're kind of going in this direction and bouncing off the wall here. And then when it comes back up, you get a crumbling motion. So it crumbles the tumble, and that causes a lot of energy. And then when the fuel air spark, the ignition is initiated with the spark plug, there's a lot of turbulence in there, and it gets going pretty fast. Whereas swirl, the challenge with swirl is, or the benefit of swirl, I should say, the benefit of swirl is when it hits the piston. Like if you have a motion going like that, and then the piston hits it, it doesn't slow that motion down, right? If it's swirling, and the piston's at the bottom of the hole, and then it starts coming up, that velocity, that rotational energy, just gets maximized as soon as the piston comes up. So when if you might down the hole, you might have 3,000 RPM of rotation. When it comes up, that just gets faster, because it's like ice skater people like putting their arms out. And then in the spin, they pull their arms in. They change the moment of inertia. And the energy has to be conserved, so they start going faster. So the same thing happens with swirl. Unfortunately, that's a good thing and a bad thing, right? You don't lose any of the energy, but the energy causes the air-fuel mixture to centrifugally stratify, so it pushes it to the outside, which is why some combustion chambers like have a little spark plug thing here and a little notch in it, because if they fling around and hit that, then they get a dense mixture in there. But if the spark plug's in the middle and you have a really high intensity swirl port, you have your leanest mixture where your spark plug is trying to ignite the fuel and there's no fuel there to ignite. So you have to think about all these things when you're designing ahead, and many, many more. But this is just like a, combustion chamber, port flow, port design 101. That's my opinion. I could be wrong. Okay, so I spent some time this afternoon flowing the stock 4.6 2-valve head. And the black line is stock valve, stock everything. And purple line is with the swirl dam removed. So gained a little bit of flow at the 1 and 2 millimeter lift, and quite a bit in the 6 through 9 millimeter. And then it kind of trailed off. So evidently that's acting like a dam in this area here mostly. Not so much here, but here. And then at the top end, it's since it's a double port, it's just shooting over the top of that, and nothing would have gone there anyway. So we have to fix that. We have to change that to a dump port to get this to go up yonder like that. So, but it's a start. Thanks for watching. If you like this content and want more, subscribe, like, and share.